Hello, guys. Back at it again. Chapter 1, Day 2. So we go from dealing with more loose definitions and postulates and things like that to some actual geometry, if you can believe it. So our topic today, very geometric things here. We've got points, lines, and planes. And we're going to kind of deal with these three step by step in that order. So big thing, I'm going to give you guys about 10 seconds. You can pause the video, go ahead and read over our standards and goals, and I want you to underline. Let's practice underlining and understanding some important vocab. So go ahead and pause, and I'll come back to you in a second. Okay, so as you look, you're going to say, wait a minute, Mr. Harris, you literally have everything underlined and circled. What's the point? I wanted to show you how this first standard takes what we learned in day 1 and kind of applies it to day 2. So we're still talking about definitions, postulates, and theorems, but now we're implementing them into some actual geometry when we're talking about points, segments, lines, and angles. And we're going to kind of be able to use this logic and this math to help us solve individual problems. So see if you can do the same thing maybe on number 2. Or standard 2, I'm sorry. Interesting. So this time, not much in the way of day 1, but we see some continuation as far as lines and points, angles, and things of that nature. And then we see 2 words in here you probably have never seen before, collinear and non-collinear. So enough of all that good stuff with standards. Let's actually start putting some of this into practice. So I'm not going to run through this. You guys are my accelerated class as far as definitions are concerned. But what I will point out is that once again, we have ourselves a postulate. Take some time to remember that much like claiming LeBron James is the best basketball player on the planet, a postulate has no proof. And so I'm going to give you guys a chance. If you need to take a moment to make sure you have down what points are, what lines are. You know, as funny as that is to say, we don't know what a point and a line is. Once again, I'm going to pause, give you guys a chance to read over, and then I'm going to come back with some highlights, so be ready. All right, back to it. So you're going to see I've got some things underlined here. And I think we all know what a point is, but let's talk a little bit about what exactly it represents in geometry. So it doesn't represent the size of something, instead it represents position. So you can see we've got 3 examples of points right here. Point A, point L, and point F. And so we can say that, point F is the highest on the paper. Of course, I'm not talking about drugs. I'm just talking about how this point is currently the highest point up on the paper. So it represents position. You could say point F is to the right of point L and point A. But we couldn't say, point F is bigger than point A or point L is smaller than point F. These dots don't tell us anything about size. As far as lines go, one thing that sometimes I know people forget is that a line is a set of all points that go on forever, infinitely. So, for example, if I'm looking at this line right here, which some of you guys may know, we would call AB. And in geometry, if we want to represent a line, we actually draw a line above the 2 points we recognize on this line. And that's the thing, you need at least 2 points to have a line. We see that in this postulate right here. Need 2 points for one line. So if we can point out 2 points on a line or on a structure, we can say, hey, that's a line. And some of you guys are probably saying, isn't there another one right here? Yes, there is. We got line AB and line CD. And sometimes we can call lines by just a letter. So for example, I'm going to call this line, that's a cursive L, by the way. I don't like using regular L's because they look a lot like ones. So we could say, hey, this line right here, There, and then look at me, I'll go and do it right there. This is line L. And I could say, hey, this is line P, this is line Q, this is line T. Things like that. Now, going back up to what we know about lines, sometimes sets of points or lines, they intersect. And when they intersect, we have a symbol we can use for these. It looks like a hump on a camel or a hill. And we call this an intersection. So you're not going to see this symbol wrong on my paper if you see it. This is actually an intersection symbol. Anytime we have a spot where two lines intersect. And speaking of multiple lines and multiple points, let's look down here at collinear points. Now this is, like I said earlier, probably something you guys have never heard of before. A collinear set of points. These are points that are on the same line. And some of you guys probably could piece that together based off the prefix co, which usually means together. Well, if co means together, non-collinear points, you can probably deduce are points that are not on the same line. So collinear points, points that are on the same line, non-collinear points, points that are not on the same line. So what I'm going to have you guys do is I'm going to have you guys list which points on this graph right down here you would say are collinear and which points you would say are non-collinear. So take a moment. You can list them out here with collinear and list them out here with non-collinear. You can go ahead and pause the video and give it a shot. All right, take a look, guys. Collinear. These are points that have to be on the same line. If we're talking more than two, 3 or so, there's only one option here, AFB or BFA would be collinear. Now, non-collinear, we actually have a couple different combinations here, and really more if you wanted to get technical with it. I just chose two. We've got GAF, GAF, those points are not all on the same line, and half, spitting bars, HAF. So we've got two just right here, but you also could have said HFB. You could have said GBF. You could have taken this a few different directions. So know that if you didn't just get both these, you're not necessarily wrong. And the last thing, the last concept we're really going to get into as far as geometry basics. We've talked about points. We've talked about lines. Now let's talk about planes. And I ain't talking about the ones that got wings. So when it comes to planes, these are a little bit more tricky. These are surfaces. So we've got, think of like the top of a desk is a good example, or a flat sheet of paper, or even a sheet of paper that's straight but maybe being held diagonally. Planes are surfaces that extend without end in all direction. So you see some examples down here, but before we really get into that, let's talk about some postulates. Remember, these are statements we trust without proof. So if two planes intersect, so there's that word intersect again, we know their intersection is a line. And you actually can see that right down here. Take a look. So these planes that intersect, we've got this plane that's vertical and this plane that's diagonal. They're intersecting right here. So there is a line where those intersect. Through any three non-collinear points, so with any 3 points that are not on a line, there is exactly one plane. Take a look. A, B, C. 3 points, non-collinear. Can't form one line between all three without having to make multiple lines. That means this is a plane, and we call that plane, in this case, M. How about this one? If 2 points lie in a plane, then the line joining them lies in the plane. So even though I said ABC are not collinear, you could say, oh, AC. These 2 points are in the plane, and so if they're in the plane, A and C are collinear. Last thing, if a plane and a line intersects, then their intersection is a point. There's only one point where this line intersects this plane, and they actually have it labeled right here for us, point A. And so those are 4 incredibly important postulates that, while not complex, are going to help us with some problems down the line. So what I'm going to do is, everybody can pause, stand up, stretch, and then we're going to hit the ground running on the next page. Well, welcome back. It stands to reason, if we have collinear points and non-collinear points, we're going to have coplanar points and non-coplanar points, and they're exactly what you think they are. Coplanar points are points on the same plane. Non-coplanar points, what a great line. Points that are not on the same plane. Man, I'm on fire with these lines. And I'm not even going to have to list these for you because I know you guys already can label what we're looking at as far as planes are concerned. So go ahead and give me some examples of coplanar points and some examples of non-coplanar points. All right, check it out. We got coplanar, SUT. All 3 of these are on the same plane. Non-coplanar, we've got NRS, MQT. MQT. Pretty self-explanatory, isn't it? Something else that you may have thought about but not really been able to reference kind of in your mind is space. Not the thing that goes on and on forever up, around Earth, but we're talking space from a mathematical sense. It is boundless, like, the space above us or around us. Sorry, I never took much astrology, but it's boundless, and it is 3-dimensional set of points. So let's kind of quantify that a little bit. Space is going to be where everything happens. It's going to be where all your points lie. So, for example, let's look at a postulate. A line, plane, and space each contain an infinite number of points. Well, yeah, we know a line goes on forever. That's an infinite number of points. A plane goes on forever. That's an infinite number of points. And if space is boundless, it's definitely going to have an infinite number of points. Now, some points in a plane are non-collinear. We know that. We saw some examples up here of some non-collinear or some non-planar points. But we also know that, hey, non-collinear is going to happen too. You have a point here, and a point here, A, B, C. Those are non-collinear. Some points in space are also going to be non-coplanar. Check it out. Here's our space. Let's call it, or not space, here's our plane. Let's call it R. We got plane R. And let's put a point out here, and I'm going to call it Q. This point out in space, again, space is everything. But this point Q is not on the plane. It's non-coplanar. In fact, I could have picked a point on the line. Let's call this D. Point D is not in this plane. Now, I'm going to give you guys a chance to stop and see how many different names you can give me just for this line alone. I'm going to give you a hint. You should be able to give me 4 names. So let's see what you guys got on this one. All right, what are you guys thinking? I know your letters may be a little bit in different order, but hopefully we've got some combination of these three combos of points, point combos, and then the line name itself, line P. So that wasn't too bad. Now things are going to start to pick up a little bit here, so just be ready. We're going to go rapid fire, and I'm going to let you guys see if you can run wild by practicing these next three. And take your time, because if you're looking at all these points and you're looking at all these letters, it can get a little confusing and you can lose track of what's labeling what. So I'm going to slowly reveal these one piece at a time by cutting back and forth. So when you're ready, you can click unpause and see how you did. First up, two different right answers here. You could have said line G, or you could have said line PT. Now, if you said line PN, you're not wrong either. As long as you have 2 points on the line connected, then that is the correct line. Next up, a line that intersects this plane, the same plane that contains the points Q, N, and P. Well, I see a line almost vertical cutting right down the middle here, and that looks like you could call that either line J, which is what it's labeled, or line MT. Same thing there, because we have 2 points on the line. And then the last one. All right, and we have plane S. As you can see down here in the bottom corner, usually the planes will be labeled or given a letter. But if not, sometimes we can label them ourselves. So plane S. I apologize, sometimes my S's look like 5s. Last page, last page. So I'm not going to have you guys, you're my accelerated class. If you want to do numbers 1 and 2, you are more than welcome to. That's where you draw and label a figure based off the relationships. I'm going to freeze the screen and unfreeze it here in a second. If you want to get some extra practice in, 1 and 2 are going to be optional. But you are more than welcome to do that right now. Boom. There they are. And if you're anything like me as we get into this next section, I sometimes struggle with being able to process what's going on with a three-dimensional object. So I'm going to try and work you guys through this just like I would want to be worked. Because when I ask you how many planes you see here, some of you guys are probably going to get a headache just looking at this. So let's count them off. We see we've got the main plane on the bottom here, plane A, so that's 1. We have this front panel of this three-dimensional shape, so that's 2. We have the back panel, TQRS, that's 3. We have this side panel, WMST, that's 4. We have QPNR, this right side panel, that's 5. And then we've got up top here, WTQP, that's 6. So we're looking at 6 planes for this three-dimensional figure, and the plane beneath it as well. And you may be asking, what about SRNM? That plane is actually already represented in plane A. How about something you guys are probably going to be a little bit more confident with? Where do you see 3 points that are all collinear? Yep, SXN. Boom, 3 straight points right there, all on the same line. And then the last one before I let you guys rock an Edpuzzle, how about our points N, R, S, and W coplanar? N, R, S, and W. And that is no, because W is trash. Just kidding. It's because it is non-coplanar. It's sitting up here, part of another plane, not part of this plane right here that we were forming. We would need to go M instead of W. So guys, I'm going to stop here, let you guys rock an Edpuzzle for numbers 4 and 5, and then we'll almost be ready to wrap up. Ooh, I know some people are going to be a little heated. Are points W and Q collinear? Yes, they are. Because a line can always be created by connecting 2 points that are on the same plane. W and Q are on this top plane up here. We can connect a line there. A line can be made between any 2 points. Now, number 5, one you probably feel a little bit better about. What fourth point makes up plane SWP? Well, SWP, okay, so it's looking like this is going to be a diagonal plane. SWP, going to be R. We got a diagonal kind of like that. Not that you can tell on this camera. But yep, R would be the magic point there. So if you want to get any extra practice in, you are more than welcome to do so. But your homework outside of your Delta Math, your practice homework that I'm going to have you guys work on tonight, and we're going to discuss some tomorrow, is to do a fun little exercise down here at the bottom of this page. We're going to name the geometric terms for each modeled object, and even those who don't have an immediate physical thing you can see there. And then on the back page, I'm going to have you guys working on problems 1 through 6. So your homework, page 3, the bottom of that page, and page 4, practice multiple choice. And be on the lookout. We're going to have a Delta Math posted, or you still have a Delta Math posted as well. If you have any questions, guys, you know how to contact me, and I'll be talking to you soon.